Hello, today we are going to start off by reviewing our exponent rules, and then we are going to switch into some new stuff with rational exponents. So, at the top, quick review of your exponent rules that you should be mostly familiar with by now. Our product rule, if I'm multiplying like terms, I add their coefficients. My power rule, if I raise an exponent to another exponent, I multiply the exponents. Negative exponent, again, if I want to turn it into a positive one, I have to move it into the opposite side of the fraction. So if it was in the top, I move it to the bottom and vice versa. Zero power, anything to the zero power is 1. Quotient rule, if I'm dividing like terms, I subtract their exponents. And our fractional exponent rule, this is one that's going to be new to us, and we're going to practice it on the back. So using those rules, we have a couple problems to evaluate. We are going to be simplifying these expressions on 1 through 8, and then on 9 and 10 we're doing a little bit of solving. So starting on number 1, I have -4, and remember when there's no exponent written, it's like an imaginary 1, and I'm multiplying that by -4 to the third power. So my product rule is what I use here. So this is going to be -4 to the fourth power. And so, remember, a negative to an even exponent is going to give you a positive outcome. And so 4 to the fourth power is 256. Okay, on to number 2. I have -3 squared, and I'm raising that to the third power. So that's going to be my power rule, which means I'm going to multiply my exponents. 2 times 3 is 6. So I'm looking at -3 to the 6th power, which is going to be 729. On 3, this is my power rule again, and because everything in here is in parentheses, I have to apply that power rule to all 3 parts. So 3 squared raised to the 2nd power is going to give me 3 to the 4th. X squared to the 2nd power is going to give me x to the 4th. And then the y, again, there's an imaginary 1 here. That raised to the 2nd power is going to give me y squared. So out of those, my x and y's are going to stay as variables, but I can figure out 3 to the 4th power. That's going to be a number, and that's 81. So 81x to the 4th, y squared. Okay, on number 4, if I'm multiplying m to the 7th times 1 over m to the 4th, that's going to give me m to the 7th over m to the 4th, and this is my quotient rule, which means I subtract my exponents, and it goes where the bigger exponent was. 7 is on top, that one's going to be bigger. So 7 minus 4 gives me 3, so that's going to be m to the 3rd. Okay, moving on over here to number 5, I've got a couple different things going on here. First thing I want to do is simplify in my denominator. I have my product rule here, so I'm going to add my exponents. So I have 8 to the 9th divided by 3 plus 5 is 8. Now I need to use my quotient rule, so I'm going to subtract my exponents, and I'm just going to get 8 to the 1st power, which is 8. Number 6, this is my 0 power rule, so everything in this parentheses is going to be raised to the 0 power. Anything to the 0 power is 1. So that one's pretty easy. On 7, this is my product rule again. I'm multiplying like terms, so I'm going to add their coefficients. And now, because I have a variable on one of these, I'm not going to be able to get a numeric outcome. I just have to leave it as y plus 6. Because whatever y is, I would just add those 2 values and get my final exponent. Okay, on 8, again, I have my product rule, so I'm going to be adding my exponents. So I need to add 5 and 3/5. Now, this one's a fraction, so that means I need a common denominator. That common denominator can be 5, so this is going to be 25 over 5 plus 3 over 5, which gives me 28 over 5. So my final answer is G to the 28 over 5 power. Okay, last 2, we're going to be using our exponent rules to find variables. So on the first one, number 9, 3 squared times 3 to the x power is equal to 3 to the 10th power. So this is my product rule, which means if I'm adding my 2 exponents, 2 plus x, that is going to result in 10. So I need to solve that for x. I'm just going to subtract 2. and I get that x is 8. Okay, 10 is similar. This one is my quotient rule, however, so I have 3 to the y divided by 3 to the 4th, and that results in 3 to the 5th. So again, when I'm using my quotient rule, that means I'm subtracting my exponents. So y minus 4 is going to give me 5. So I just add 4, and I find that y is 9. Okay, so everything on this front side was review up to this point. Now we are going to look at rational exponents, which means they are fractions. And what I do with my rational exponents is these can be rewritten as radicals. So if you have a radical, you can actually rewrite it as an exponent where the index of your radical, the number outside, is in your denominator. And if you happen to have another power in there, that would go in your numerator. So again, the index, if it's just square root, that means it's 2. If it's a cube root, it's going to be 3, and so on. So the index of your radical goes in the denominator, and if you have another exponent that your inside is being raised to, that goes in your numerator. So on this first example, we are going to rewrite all of these using rational exponents. So I'm going from radical to exponential. So on this first one, I have the square root of x. Remember, if there's nothing written here, it's a square root, which means your index is 2. So this is going to be x to the 1/2 power. I have x to the first power in here. Remember, we just assume it's 1, so we don't have to write it. So that's in my numerator, and the index of my radical is in the denominator. Let's practice again. On part B, I have the cube root of 6x. So my index here is 3, so that's going to be my denominator. And this is being raised to the first power inside, so that's just going to be to the 1/3. Now what's important here is that both the 6 and the x are in my radical, so those need parentheses. I need to establish that both the 6 and the x are going inside the radical. If I did not put the parentheses there, all I'm saying is that the x is being raised to the 1/3 power, and the 6 would be on the outside, and that's not accurate to match what's on part B. So whatever is going inside your radical needs to be in parentheses. Okay? Moving on to C, I have the square root of x to the 5th power. So that 5 is going to be in my numerator, and the index here too, that is what goes in my denominator. So x to the 5/2, or 5/2 power. Okay, last one for this set, I have the cube root of 3x to the 4th power. Again, both the 3 and the x are inside this radical, so I want to make sure I'm putting them in parentheses. And then for my exponent, my index 3, that's my denominator, and the 4th is going to be my numerator. Okay, now we're going to practice going the other way around. We are going to rewrite the exponents as radicals. So this first one, x to the 1/3, that is going to be equivalent to the cube root of x. Remember, your denominator tells you the index of your radical. On B, I have x to the 1/2, so that's going to be the square root of x. On C, I have 7x to the 4/3. So what that means is both the 7 and the x are going to be inside my radical. My denominator is 3, so this is a cube root. And then I have my numerator of 4. So there's actually two ways that I can write this. I can put the 4 outside of the radical, or I can put it inside the radical as long as my 7x is in parentheses, because again, that exponent is applying to both parts, not just the x. Okay, last one, 3x is in parentheses, so that means both parts are inside my radical. My denominator is 3, so that tells me it's a cube root, and my numerator is 2, so that tells me that I am squaring this. And again, just like we did on part C, I can rewrite this inside as well. Okay, on the next one, we are finding the value of a. So what I need to do is simplify everything on the left to get my final exponent a. So let's start using some of our exponent rules. I have x squared raised to the 1/5 power, so that's my exponent rule, which means I'm going to be multiplying they're my two exponents, so that's going to be x to the 2/5. And then what I can do is rewrite this 5th root of x as a rational exponent. So that would be x to the 1/5. And now what I have here is my product rule. So I want to add my exponents. Well, 2/5 plus 1/5 is 3/5. So after I'm done simplifying all of this, I have x to the 3/5 power, which means a is 3/5. Okay, the next thing we're going to take a look at is our negative exponent rule. Remember, if I want it to be positive, I have to move it to the opposite side of the fraction. And what we have to pay close attention to here is, what is the exponent attached to? Is it all of things or just one part of it? So on part A here, -4 times x to the -2. Because the -4x is not in parentheses, the exponent only applies to the x. So -4 is going to stay put, and I'm just going to move the x squared to the bottom to make it positive. Same story on part B. I don't have parentheses, so the -1 only applies to the x. But then on C, notice how this is all in parentheses to the -2 power? That means it applies to everything. So to make it positive, I have to move my entire trinomial into the denominator. Same thing on D. The 5x is in parentheses, so that means the whole thing is being moved into the denominator. Now I could go ahead here and simplify this out. This was going to be 1/5 cubed x cubed, and I know that 5 cubed is 125 x cubed, just because those are constants. Okay, last thing we're going to talk about is solving equations that involve rational exponents. So we're going to start out with these by getting the exponent alone. So the x needs to be alone. So you're going to use your typical Algebra 1 skills to do this. Starting on A, I want to get this alone, x to the 6/5. So the first thing I need to do is add 4 to both sides. And then I'm going to divide by 7. And I get 262,144. These are big numbers. Once I have my x with the exponent alone, the way I undo this exponent is I'm going to raise both sides by the reciprocal of my exponent. The reciprocal means you're flipping your fraction upside down. So my reciprocal of 6/5 would be 5/6. So I'm going to do that on both sides. And think about why I'm doing that. On the left side, this is my exponent rule, so I would be multiplying my my exponents. So that would be 30/30, which is 1. Once I have x to the first power, that means I'm solving for x. So I'm going to need a calculator for this, of course. So 262,144. Use your caret top right here, your caret top, and you just say 5 divided by 6. You can put rational exponents in your calculator, and there is my answer, 32,768. Let's do that one more time. Again, I want to get x to the 5/8 by itself, so the first thing I'm going to do is subtract 12. Then I'm going to divide by 4. And again, I'm going to raise both sides to the reciprocal of my exponent. So that's going to be 8/5. With my exponent rule here, that's going to be 40/40, which is 1, so x to the first power. And this I need to do in my calculator. 3125 to the 8/5 power, 39,625. And that wraps up our notes today on exponent rules and rational exponents.